Okay. Hello, everybody. Welcome again. This is, I guess, yeah, this is the sixth time. I did this during the first test as well. We had very few people that time, but it's grown a bit.
Because I didn't know about it.
Yeah,
I
it was
didn't know
only
about
like,
this.
yeah, it's okay. I mean, it was the first. I was like, maybe we'll do something, but okay. There is this. I mean, this is it. I mean, you're taking this test, and then 1 week after this, so you're almost done. And then Calc 2.
Yeah.
Yeah. I won't be teaching recitation for Calc 2, but I'm open for private tutoring or anything, you guys. Or I might still be at the MAC. I don't know. I'm going to be actually teaching class, so it might be a little harder.
Okay. What class are you teaching?
What? Yeah. I'm going to be teaching. I'm teaching 221. Yeah. Yeah, that's 221 is Calc 1 for technology. So it's basically your class, except a lot less rigorous. I mean, your class really isn't super rigorous, but it's very like they ignore limits basically completely.
Okay, why aren't we taking
Wait, what are we talking about?
They ignore limits. Why aren't we
In what
taking
class?
And
221.
221.
Why aren't we
What's
taking
221?
It's Calc 1 for technology.
Why aren't we taking
Okay. Anyway, we're not here to talk about 221. We're here to talk about 165. So let's bring it in. We have a few problems up here on the board to do. 3, 4, 5, 6, 8, 9, 13, 15, 16, 18. I'll repeat those numbers again as we go to each one. But those are the ones that we're covering. So if you wanted to cover another one, I guess you should have been here or been watching. So I'm really sorry. Anyway, we'll go ahead and get started with this. So number 3. Okay. For those who are in my recitation, you probably this probably looks familiar because I talked about this already slightly. We have y equals cosine x and y equals sine 2x. Now there is an aspect of this I do want to talk about a bit more. And then x is 0, and then x is it pi over 2? Good. Okay. And we're finding just the area between these. Okay, so we want to graph both of these, right? So we don't need to do the whole graph. I'll just go to think about, it's having a pi sort of thing. So what the graph of cosine, where does it start? At 0, what's cosine? 1. At pi over 2? 0. And then at pi, it would be minus 1, yeah. I forgot to make it in there. And then it's it's fine. I want to get like a general graph on there just to be able to close it off easier. So I know it only goes to pi over 2, but we should know how to graph cosine completely. Okay, so it's good. It's a good reminder. Okay, now sine. What's the difference between sine of x and sine 2x? It's not amplified. It's squished. Yeah, it's compressed. Yes. If you have a fraction in here like that's smaller than 1, then it's going to stretch it out. But if it's bigger than 1, then it's going to compress it. It's going to shrink it down. So, and what that means is that normally sine has a period of 2 pi, but now it's going to have a period of pi because I take that 2 pi and divide it by 2. So what normally is the sine graph, which is going to be something like this, right? Starts off this way and then picks up. It's going to double that speed. So it's going to hit 1. Sorry, let me redraw that. Hit 1 somewhere in the middle, and then pi over 2, -1, pi, and it would start again. So it's just doubling its speed. Okay. Once again, though, we're only concerned with this region, so it's okay if you only get this part, but I think it's good to kind of get the graphs in general. Okay. Anywho. And then we're bounded between x is 0 and x is pi over 2. So that gives us 2 distinct regions that we're bounded between, right? There's this one, which is bounded between x is 0, y is cosine, and y is sine 2x. And then there's this region, which is just bounded by the 2 curves. Because it's 0, they intersect with each other at pi over 2. Okay. Now, does anybody know what value this is that they intersect at? If not, it's okay, we're gonna solve for it, but can you, it's a little hard to guess, right? I can't just look at that and be like, oh, it's we don't know. Okay, so we're gonna need to solve for this, right? To do that, to find where it intersects, right? Right, we're gonna set them equal to each other, right? So I need to take cosine x equals sine 2x, okay? So this is another good reminder to please remember your trig identities, okay? I was pretty glad. I noticed I'm grading some of the quizzes already, and for the derivative problem, I noticed a lot more. Notice that sine squared plus cosine squared is 1, so then it cancels out nicely. So thank you for that. I appreciate it. But we have more trig identities to remember. So cosine is just cosine right now. How can I rewrite sine 2x? Good. Cosine x, sine 2x is the same thing as 2 times the sine of x times the cosine of x. Okay. So who thinks we should divide by cosine? No, that's a bad idea. Don't do that. We want to set this equal to 0, right? Because that's always a nice method to try to set everything. So let's move this cosine perhaps to the right side. Okay, by subtracting. So that's going to leave us with 2 sine x cosine x minus cosine x equals 0. Okay. These both have a cosine x in common, right? So what can I do with that? Factor it out. Good. Cosine x times 2 sine x minus 1 equals 0. So inside, now there's a lot of places where cosine x is 0, but more specifically inside our region, when is cosine x equal to 0? Okay. All right, which I'll write that. So we need to set cosine x equal to 0 and 2 sine x minus 1 equal to 0. Just like when you're doing a polynomial, you'd set each piece equal to 0. So, and as we already said, cosine is 0 whenever x is pi over 2. And there's other places, but we don't care about that in this first section. Okay. Which this one seems a little redundant because it already crosses at pi over 2, so it's not completely necessary, but it's good to know that it closes off there. How do I solve this one? 2 sine x plus 1 equals 0. Yes, we're going to add 1.
Wait, why is it plus?
It is minus 2 sine x minus 1. Right, we need to add 1 to both sides.
Oh.
And then we'll divide by 2 as well. So we need to divide the 2 off. So that's going to give us, so I'll divide by 2, divide by 2. So we're going to get sine of x is 1/2. Okay, again, we'll go back to trig. Sine of what angle gives me 1/2? Pi over 6. Good. Okay. Again, there's multiple, but we only care about the one from 0 to pi over 2, which is pi over 6. Okay, so we have pi over 2 and we have pi over 6. Pi over 2 is not as helpful for us, but pi over 6 is. Okay? Because pi over 6, now again, as we said, we have 2 regions to worry about. Okay, so I have to do how many integrals? 2. Okay, so the first integral is going to go from 0, right, to what? Pi over 6. Okay. What's on top? Cosine x. Good. And what's on the bottom? Good. And then we have to add the other one, which will be from what to what? What's that one going to look like? Yep. So now sine 2x is on top, so we need to recognize that. Okay. So then we would evaluate this out, and that will give you the answer. Okay. Do I need to talk about how to evaluate this?
Yeah.
So the antiderivative of cosine is what? Sine. So that's fine. How do I find the antiderivative of sine 2x? So we'd have to use u substitution. I'm gonna offer a quick alternative instead of having to think about u substitution every time. So if I'm integrating, I'll just use sine in this case, but it's the same way for cosine, or actually I'll use cosine in this case. But no, we'll talk about sine, sorry. Just because we're already using sine. Don't want to get confused. Okay. So as you said, we have to do u sub. If I have a number in here, then I need to think about u sub, right? So u substitution would say u is going to be a times x, right? So what would du be in that case? Right. Okay. A dx.
Sorry, I was thinking about 2x in here.
Oh, you're good. Yeah, so a is just a constant, so then you just do the derivative of x, which is 1. So you have du is a dx. Or more specifically, we can write this as du over a is dx. Okay, so what's going to happen? I'm going to bring that 1 over a out. And then it's going to be the integral of sine of u du. What's the integral of sine of u?
Can you ask that again?
What is the integral, the antiderivative of sine u? Negative cosine u.
Yeah, negative cosine.
And what's u?
X.
And then and in this scenario it would be plus c. Okay. So the reason I did that is because you could go through and do u sub, or what's the only thing that happened? I mean, you integrate and it was cosine, and then you just divide it by whatever the number was inside. So in this case, I guess since I'm not speaking for this one, I'll write this one real quick. This would be negative 1/2 cosine 2x.
Which one?
Here.
Okay.
Yeah.
I was confused by where you were pointing, and I was like,
Sorry. Yeah. So this is because these are adding.
Yeah.
I'm doing this one right now.
Okay.
Those added, whatever the number would be, the final answer. I'm just showing this guy right now would be negative 1/2 cosine 2x, and then minus sine x, and then you would evaluate it from 5 or 6. Okay. So all that being said, we should be able to plug in numbers from there, right? And then if you ever have a number on the inside of sine or cosine, you have 2x, 3x, and you want to do the integral of it, just do the integral of the thing of sine and cosine, and then just divide by whatever the number is. Okay, it'll save you a lot of time. Save you a lot of unnecessary work for a simple result.
Yeah, that's.
Yeah. I'm tutoring class right now, and one of the integrals they're doing is they haven't learned u sub, and I'm not sure if they will, but they have one that's similar to that, but they don't learn u sub, they just kind of learn it as that. And so I think that can be useful sometimes. Be like, oh, whenever you can also think about it as when I take the derivative of this, you multiply by a. So if I'm doing the antiderivative, I divide by a. Cool. Questions before we move on?
Why does wait a second?
Okay.
Why does sine 2x equal 2 sine x cosine x?
That's a trig identity.
That does not make any sense to me whatsoever. How does that work?
I took.
I
know I've heard this today, right? Apparently you take trig in high school.
Yeah.
No, never. Not a thing.
So I could show you why I don't think that this is the class in the time for that though.
Is it a lot?
Yeah.
Well, it's
Okay,
the way to prove it that I'm thinking of is not something that unless you've taken 171, you would probably know. So I'm probably gonna leave that off, but it's true. Just believe it. I promise. Also though, what you can do. Do you remember your sum and difference identities for trig?
He didn't take trig.
I don't.
You didn't take trig at all?
They didn't,
No,
they don't have it on it. That's
You
why
guys didn't have to take trig at all?
No.
I did. I mean, I'm from Indiana, so like I took trig. That's why he's confused. He never took it.
I'm sorry about that.
Yeah, that's kind of, you're kind of SOL on that one, but I don't know.
Let's sit down sometime. I want to teach you trig.
Yeah.
What is it? Can we quiet? Sorry, can we quiet back down real quick? Oh, don't race.
I don't understand what it is.
I'm sorry.
Yeah, I don't understand.
You don't understand what? Yeah. So I was just A is just some random number. I'm saying this is a general case. Even if you had cosine, it worked the same way. I just have sine of A times X. So I have some number inside the sine, right? So I did U sub on it to get the integral because I know how to integrate sine itself. And I showed that all that happens is you divide by the number inside. Okay, so I use it over here. Now you can go through and just do U sub yourself as you do the problem, but I think you'll save time by understanding that sort of principle. Whereas if I just have a constant times X, I'm just going to divide by it. Okay, let's keep.
The other way is that that is going to make me just lose all the entire rest of the time.
Okay, number 4. So I'll set this one up. So this is volume of the solid obtained by rotating the region in the first quadrant, bounded by y equals x squared and y equals 9. And we'll rotate this about the y equals x squared and about the run.
Wait, which one is it?
In the first quadrant. Yeah, this is number 4. Okay, so the question was is to rotate the region in the first quadrant bounded by, so this is the first quadrant, and then bounded by y equals x squared and y equals 9. And we're going to take this and rotate it about the y-axis. So real quick, just to kind of address here, this is the graph of y equals x squared. I only did I mean, technically it has another side, but we can worry about just this half. And then y equals 9 is just a straight line. So I actually heard yes, it is going to be it. So yes, and I'm going to address what like why you know for sure that you should just use shells on this problem. And we have y equals 9 here that bounds it. That's just a straight horizontal line. And so this is going to be the region. Okay, so yes, you always want to look at what the function is that you start off with, right? So if all of your functions are in terms of x, don't try it. You shouldn't really try to change it if you don't have to. Or if all of your functions are in terms of y, don't feel obligated to change it if you don't have to, right?
So wait, what would this be in terms of y equals x squared? Is that in terms of x or in terms of y?
So it's a function of what? It's y equals x squared. So that's a function of x, or is that a function of y?
That's my question.
So that's what I'm asking you.
Is that a function of x?
It's a function of, so it's a function of x, right?
Okay.
Because look at, yeah, think about y as,
That's what I was, that's perfect.
yeah, that's what I want to get across though, right? Is you wouldn't want to say x, you want to say y is a function of x in this case, right? Because x is being squared. And so it's going to be all strange thinking about, oh wait, well the function's squared, it's y, I don't know what's happening. So whatever the thing is, all the, like whatever's happening to it, right? You want it to be, you're going to say it's a function of that thing, right? Now, if you have an equation that looks like this, then it's a function of y, right? You wouldn't want to say this side is a function of x. So this is a function of x in this case, okay? And because it's a function of x, we can pick this vertical rectangle, okay? As we draw through. Why is that? What is it?
You have a top and a bottom?
Well, We do, right? But what's preventing me from drawing it this way and not this way?
The only way I know is that it's not touching both functions. That's how
That
I
would
remember it.
be a dy, right? And then
Yes.
That would be
solve
a
for
dy.
Good.
y.
That's what I'm looking for. So since it's a function of x, I want to integrate with respect to x, and so I need a dx, right? Whenever we're integrating, every time when we talked about rectangles, at least in this context, right, I was always concerned with, well, what's delta x, right? Because we had a constant width of boxes. That's exactly what's happening here. Since I'm dealing with a function of x, I'm looking for a delta x, a dx, right? So that's why I want my rectangle to be up and down. Okay, I want the height to be here. Okay, so with that being said, since it's a vertical rectangle and we're rotating about the y-axis, is this method or is it shell? It's going to be shell. Good. And that's because this is parallel to the axis you're flipping around. Okay. If your rectangle is parallel to the axis you're rotating around, it's shell. If your rectangle is perpendicular to the axis you're flipping around, then it's disk or washer. Disk is washer, except the inner radius is 0. I think I talked about this in one of the recitations, but don't stress about when to use which one. They're the same method. Okay. Okay. So if this is shell, we need two things, right? What are the two things I need? We need a radius and we need a height. So what would be the radius in this context for shell? It's just going to be x.
Why?
No, x. I'm just kidding. So it's x because where our axis we're flipping around is the y-axis, right? And I'm considering I want to represent the distance from that axis in some way. And so the easiest way to represent that is just by using x. Because to say I'm at this value of x says I'm that far away from the axis I'm rotating about. Okay. What about the height? What is the height? 9 minus x squared.
Oh.
Okay. And so this is a similar idea to the area between curves, right? I want this region, and so I need to subtract the higher minus the lower.
Yeah.
Is height? Yeah, parallel to the axis it's rotating around.
Is height parallel?
Yeah, like that's what it.
Well, the height in this case is perpendicular to it. The height should, if you're talking about shell, in that sense, it should be the height you're looking for is up and down.
Okay.
So you're moving parallel to it, yes.
Yeah.
But you're not like our height's not going to go this way. That's not the height. That was the radius we talked about. The radius was x, and that went left and right. We're talking about the up and down now, which is our height. And that height is going to be 9 minus x squared. Okay, so shell, I'll write real quick, a to b of RH dx. So what is the integral going to look like in this case? Right. I guess let's address real quick. What are the bounds? Okay, why is it 3? Right. You would set x squared equal to 9, so the next would be plus or minus 3. Well, we only worry about the plus 3. And then 0 is a given. Okay, so we go from 0 to 3 of r times h dx. Okay, we can evaluate that. I'm not going to do that. I'm going to leave that to you. That's just distributing and power rule. Okay, so but the setup is the important part. Does that make sense?
Can we go back to the 3?
Go back to the 3.
Yeah.
The 3. Here.
Yeah.
Yeah. So remember when
Is
we're
that point 3?
No, it's
That
just
point up there?
no. So you're setting to find the balance. You have to set like you don't know.
So
You
that's
set
at 3? Okay. That's
both
what I meant.
equations equal to each other.
right, and it's because x squared equals 9 when x is 3.
Okay.
Yeah, that's how you find balance.
You can set them equal to each other, right? Anytime you want to find an intersection, you set them equal to each other. And so we get that. Okay. 4 questions, comments, concerns. I'm glad we're going through these. Okay, number 5. Number 5 says, was this the one? Oh, okay. Yeah, so this one's a little different. It's not really that much different, but it's you'll have to put in a little more work before you can do that. And the area.
Okay.
So we have a point at 0, 0, 2, 1, and 1 negative ones. Okay, and we have a triangle.
Weird.
So weird, because there's nothing outside that says Daisy.
Now, for some of you who do who have taken trig,
What's his name?
or who have like maybe remember from geometry, it depends on what they taught in class. You could actually
John Tees.
find the length of each of these sides and then get the area of the triangle from there. But we want to use calculus to do this, of course. So we're not going to do that. What is it? That's the word. Do we do calculus?
Are we allowed to use this?
No, it says use calculus. So there has to be a calculus used in, which means that a limit must be involved in some regard.
This man's using the easy.
What?
Get on this man's head.
What method did he use to do it? Did he get the length? That's not the easy method. That's the method that's the calculus
That looks
method.
easy then.
That does not look like no calculus.
That is not.
Well, because he hasn't actually found the area yet. He just found the lines. Okay, so
Oh, wait.
before we can use calculus on this problem, we need to figure out what these equations are that we're being bounded between,
Cool.
right? Because each of these are some sort of line. Okay, so yeah, and good with slope time. We need to get some slopes. Okay, yeah, we're gonna need a bit of y equals mx plus b. Okay, so let's do. I'll call this 1. We'll call this 2. And we'll call this 3. Okay. How do I find the slope of line 1?
Oh, yeah,
Yeah. Y. Well, yeah. Actually, the y1 is going to be 1/2 x. Okay. And the reason, so you do 1 minus 0 over 2 minus 0. So that's the slope. It's 1/2.
do like the y2 or x, whatever the thing.
Y minus y1 equals m times x2 x
Yeah,
minus
that-
x1.
See, that's a little too much, like, that's a little too much.
Just a damn heck.
That's not a distance one.
You said y1 minus y2.
No, I said y1 minus y2 over x.
Oh.
x2 minus x1.
It's supposed.
Is this better?
No. Okay, never mind. It's not what I already did. It's not what I'm. never mind.
minus 0 and 2 minus.
So to reiterate real quick, the slope of this line is going to be 1 minus 0 over 2.
That's what I was talking about.
Yes. Okay. Okay. I was wondering where the disconnect happened. I get it now. Okay. So to find the slope, we do y2 minus y1. What is it? There's another disconnect now. Okay.
Okay, just keep talking. Maybe I'll-
Yeah. Let me finish the. So the slope of this line is going to be 1 minus 0 over 2 minus 0, right? y2 minus y1 over x2 minus x1. Okay. Once I have that slope, right, we can use point slope form to get the equation, right? What XO would you like to use in this case? Yeah, X naught, Y naught. I call it XO, but 0, 0. It's just use 0, 0. I know you said that. That's I was trying to recognize that. So we do y minus 0 equals 1/2 times x minus 0, or y equals 1/2 x. Okay. Any time you actually have a line that passes through the origin, it's just simply going to be the slope times x. Does that make sense? Because the y-intercept is 0, so there's nothing to, you should get 0 at
Can you
0.
also count the square if that's slope?
Yeah, exactly, that's true. Yeah, you could, which is the same thing as doing y2, which is the same thing as doing y2 minus y1. Okay, so that's the first line. So this is this line, M2. So that's this line now. I find the slope by doing 6 minus 1 over -1 minus 2. Okay, real quick, want to mention, it doesn't matter which point's first. You're going to get the same slope either way. Okay, so 6 minus 1, 5, -1 minus 2. Good, so that's going to be -5. Okay, so in this case, we can't use 0, 0, so there's a little bit more work involved. But so which point do we want to use? Yeah, we'll use 2, 1. So y minus 1 equals -5/3 times x minus 2. Which is, so y is going to be -5/3 x plus 10/3 plus 1. So y is going to be -5/3 x plus 13/3. Makes sense where I got 13/3
Yeah,
from.
'cause
Good. Okay, so I multiplied the -5/3. I distributed the -5/3. And then, so that gave me 10/3 and -5/3 x. And then I added 1 to both sides. 10/3 plus 1 is 13/3 because 1 is the same thing as 3 over 3. So 3 over 3 plus 10 over 3 is 13 over 3.
Wait, did you do the minus line?
What is it?
Did you do the?
Heads or tails?
Yes, because of the point. Yeah, so go from this equation up here. You pick the y-o, x-o, or x naught, y naught that's in here is going to be whatever point that's on the line. Okay.
Oh, yeah, because it's not MX plus B formula, it's a different.
Right. It's point slope. If you have the y-intercept, then by all means use slope intercept. But if you it's always safer to just use point slope if you're not sure. Okay. M3 is going to be 6 minus 0 over 1 -1 minus 0, which is what? -6. Okay. I can put this in a point slope form, but again, it's 0. We have 0, 0 as a point.
I've never seen that guy.
I could skip right ahead and just call this, right, because the zeros are going to go away, just like this one. This is going to be y is -6x. Okay, do I need to explain that? No. Okay, cool. So we have y equals 1/2 x. We have y is -5/3 x plus 13/3, and we have y is -6x. So now we have our equations. Okay, so if I want to find the area between them, what do I do? So we're gonna integrate. How many integrations do I have to do? Why is that?
Because we have 2 different equations after the origin point.
Right. So on this side, it's one thing, right? We're bounded between y equals -6x and y equals -5/3 x plus 13/3. And on this side, we're bounded between y equals 1/2 x and y equals -5/3 x plus 13/3. Okay, so I'll write that integral over here. So my first integral is going to go from what to what? Good. Yeah, we don't even have to worry about, setting things equal to each other because it's already given to us, right? And so we're going to take -5/3 x plus 13/3, because that's on top, right? Minus -6x dx. Okay.
And you know 2 pi or pi equation.
so the question asks to find the area between,
Yeah.
right? If you're finding the volume of a surface,
Oh, that's-
then yes,
okay.
but we're just finding the area in between. Oh, yeah, I hope you don't have to worry about doing that here as well. Yes,
How do you know it's not 0 to -1?
how do you know it's not 0 to -1?
Like on the integral.
Well, you always do smaller to bigger. So
Oh,
-1 is
right.
smaller. No, you're good. No, you're good. No, no worries.
I would have asked the same question. I would just. Don't worry about it.
What's the next one gonna look
I
like?
was just-
0 to 2. What's gonna be in here?
Same thing, but replace exactly with,
Good. Okay. I'm not gonna solve this. We don't need to. But it's 7. Okay. There's a little bit of work here, but they're all lines. It's just subtracting x's and all that. So that's really all there is to it. Okay. So if you just have a shape, right, and you're wanting to use calculus to solve this, you need to get the equations first. I need to see what the curve is I'm working with. Okay. What is the integral again? So this is the integral over here. I'm not sure what exactly is meant by the question. I mean, this is the integral we're doing. The integral in general is kind of a representation for the area between under a curve. It's also just a general like the antiderivative of a function. It kind of depends on what's on it. This will be the area under a curve. Okay. Okay, let me real quick address 6. That one shouldn't take long. I just need to talk a little bit about. We're taking the area in the first quadrant bounded by y equals x cubed and x equals y cubed in the first quadrant. About, is it the x-axis? Okay. Okay, so this one, we have a function of x and we have a function of y. So you have a little bit of an option here of what to do. Now I would suggest that if some things in terms of x, then I would just put everything in terms of x, just because that's more natural. But you can always do it the other way. I think the problems would work out to be the same. It just changes which method you do, right? So let's just talk real quick. Y equals x cubed looks like this, okay? And then x equals y cubed is basically that same curve, except it should be turned more towards the x direction. So you should get something that looks like that. Okay, so imagine you notice the letters are literally just swap places. And whenever you have that happen, that is just a.
So could we just do the quadrant and then multiply by 2?
Well, it's only the first quadrant of the problem. So you only have to worry about this quadrant, okay? So let's say if I took this and I solved it for y, so we got y is the cube root of x. Okay, because that's what that other curve is as well. Okay, what would my rectangle look like in that situation?
And down, yeah.
It's up and down. So what method would we be doing? This would be washer, right? Because we have a vertical rectangle and it's perpendicular to the x-axis.
Oh, we're going with the x-axis.
Okay. Now, what if instead I were to take this equation and write it as x to the cube root of y? What would the rectangle look like now?
It would be, and then it would be this.
And then it would be shell. Okay. So whichever whichever letter you choose has bearing on what it turns into.
So
Okay.
why? I know that if it's like x equals, then it's like horizontal, but how do you know that it's a vertical just by like y equals x cubed or x equals y cubed?
What is it?
Like, how do we know that it's a vertical on that one?
How do we know it's
On this one, yeah.
Well, that wasn't dependent on the graph, like what the graphs were. It was dependent on what they were functions of. Right. So initially, right, I said let's let y equal the cube root of x, right?
Mhm.
And so we had no, not that. Definitely not that. Definitely not the x root of 3. So in this, we had y equals x cubed and y is the cube root of x, right? So I needed dx, right? So I needed the thin part of my rectangle to be here. So that meant that I needed a vertical rectangle. But if I instead took this equation and wrote it as x equals the cube root of y, then I needed dy, and then the thin part needed to be this direction. And so that would be shown. Okay. I don't feel like I need to work through that. I think we've already practiced a few examples and it should be similar to those. I don't think either method is better than the other one, at least from first thought. I could be that could be wrong, but it ends up being a similar process. Yeah.
So if you were to do the shell, it will if you were to do the shell, then the y to the cube root would be on top still, like whenever you subtracted the two.
Yes.
Oh,
So it would be so if we were to do shell, right, and you're figuring out your height, then my height needs to come from this axis up, right? So then this graph would be higher and this graph would be lower relatively because it's farther away in a sense. So yes.
Would it be like y to the third minus the cube root of y?
Well, in this sense, in this case, it'd be the cube root of y minus y to the third.
Oh, okay.
Because cube root of y is farther away.
So if you put it in terms of x here, would it be washer? And if you put it in terms of y, it'd be shell?
Yeah, function of x, it's washer. Function of y, it's shell. Okay, that's not always the case, but in this example, it was.
So wait, what was the circumstance, like what are the circumstances for that again?
Circumstances for this and shell?
Yeah, so like if this, what would make it shell if you were parallel to shell?
And then how do we know the radius on that one? How would we know the radius?
Shoot, hold on. I meant to draw it the same way.
We did a shell problem?
Okay, so I drew both of them vertical, but you would also think about it in a horizontal way. So like I said, I could draw both here. If the rectangle is parallel to the axis, then it's shell. If the rectangle is perpendicular to the axis, then it's disc or washer.
Oh, yeah, I think.
Okay, yeah, so to get, I think I heard how to get the radius in that case. It should just be y if you're doing shell.
Well, but for washer.
The outer radius and the inner radius?
So like, yeah, because the washer method, I know it's the outer versus the inner, the R, big R.
What's x?
So what's farther away from the x-axis in that case? Is it the cube root of x or x cubed?
The X.
X cubed is farther away, so that's gonna be your outer radius. Okay, number 8. Okay, everybody strap in for number 8. Okay, so so
That's the one on the board.
yes, so this is for those who did the homework, this was
5.1.
was this 5.1?
It was like the last problem.
The last problem on 5.1, this is that problem. And it involved, so we have y equals x squared and we have y equals 4. Okay, and the question is, what b value do I choose so this is y equals 4. What b value do I choose so that whenever I use that y equals b line to cut the area, that the top area, I'll get to it in a second. The top area, A1, I'll call it, is equal, well, actually, should be all this right there, A1 is equal to the bottom area, A2. Yes. Okay, so you're saying, okay, I want to perfectly slice this object so the top and the bottom are equal in size. Okay. Not a bad concept to start off. I mean, the problem really isn't bad, it's just tedious to work out. So let's think about this, right? Let's talk about A2 first, because A2 looks a little easier. Okay. So where is x squared going to intersect b? Not at b.
Oh.
Right? So
Oh, yeah.
we need x squared to be equal to
We're gonna
b.
be the square root of b.
Right, so we need plus or minus the square root of b, right? So this point is gonna be the square root of b, and this point is gonna be negative square root of b. Okay? So if I want the area of this region, how would I find that? If I have know where it intersects, I know the curves, how would I write that area?
Negative b to b, identical negative b to b.
Root b to root b. Uh-huh.
And then x squared.
Not x squared, right? Because x squared would give us, if we just did x squared, it'd give us everything down here. I need in between b and x squared.
Minus x.
B minus x squared. Not that I know of. Even this is the part that's simpler though to write. Okay. Okay, question. How many integrals do I have to do up here? For A1? Not one, not two.
3,
Three.
4,
Why?
5.
We have to do 3 because, so look at negative root b and root b, right? From here to here,
Okay, never mind. I see it now.
I'm only bounded in between y equals 4 and x squared, right? B doesn't matter in that area, okay? Same thing with this side. If you wanted to, these are the exact same size, so you could technically just double that.
Oh,
Okay, so you might spare you the trouble and just do 2 times that. Okay. This area then is only bounded between 4 and b, right? So I have to do a couple of integrals, at most 3. Okay. So what is this first one going to look like? Okay, where is this cross? What point is this right here? Which is when?
2.
Right, 2 or minus 2, right? So I'll put, so this is x is 2 right here, and this is x is minus 2. Right there. Okay, so this first integral is going to be the integral from negative 2 to what? Negative 2 to negative square root of b of what's on top in that region? 4. What's on bottom?
Or
X squared. Okay. Now, as we already said, if you want to spare you the trouble, I guarantee you should be able to tell that these 2 areas are the same size. So just go ahead and multiply that by 2.
Can you go over the bounds again?
Yeah. So x squared intersects 4 here on this side, right? So that's the first bound. And the second bound is that minus square root of b, right, from earlier. Because as soon as we cross that, then we're not bounded by x squared anymore. We're bounded by b. For
Okay,
A1.
and then give me,
How do you get 2?
How do you get 2?
Yeah.
This area and this area are the same size. You could do both. I'm not saying you can't. I'm just saying we should be able to tell from the picture that they're the same size.
where's the 4 minus x squared again?
So 4 is the top curve in that region, and x squared is the bottom curve in that region. Right? This is still x squared. Right here,
Oh, okay.
right? Not b.
Gotcha.
No, but like, where do you get 2 on the x-axis?
Oh,
You just
here?
put it there.
Oh, because we want the place where x squared is equal to 4,
Oh, okay.
right? Where these curves intersect. Sorry, I confused the question. Okay, so we get this. So this is A1 equals 2 times this plus, what's the area of this A1 region here? Or what's the integral for it? I want to ask you to just say what it is. But the integral from what to what? Huh?
No. It's square root of b.
Square root of b.
Negative square root of b to positive square root of b.
Oh, yeah.
And then what are the curves I'm bounded in between? So I'm going to do 4 minus b dx. Yes. Well, this is, wait, what is it?
That, A1 equals to, because you can take this x squared, split it up into a negative root y and a positive root y. And then you can find the distance between a roots and compare A2 to A1.
Yeah, you could do that. You would still have to deal with the square root of b at some point in that problem, just because you'd be able to deal with the root x instead. And so that might be harder to integrate. These ones are pretty easy to integrate themselves. And so if you turned it, you're going to deal with the square root of x. So then you're going to have to do a little bit more of 2/3 x to the 3/2. And so this is easier to integrate, but you're absolutely right. Okay. So to solve this, I just need to take A1 and set it equal to A2. Okay. There's a lot of integrating in there, but I promise it actually does have a nice answer. Do you remember what it was? What is it? Well, so let's think about what's going to happen, right? I can integrate 4 minus x squared, right? Into what? What's that going to be? Yeah, so x cubed over 3. I'll write it like that. And then we're going to integrate this or evaluate it from -2 to minus root b. And then plus, how do I integrate this? Minus bx. B is a number too, right?
Oh, yeah.
So I can just write that as 4 minus b times x, because it's just a constant. And then I integrate that from minus root b to positive root b. Okay. So what's going to happen is all the x's are going to be solved with b's, right? And so you would just have an equation where you have to solve for b. Okay. And then you can also integrate that one and get it. Do I need to work farther on this? Is that good?
You want to know what b is?
Yeah. What is b supposed to be?
2 cube root 2.
So 2 to the 4/3, basically.
Yeah. But it's after all.
So let it be known, if you cut this at 2 to the 4/3 power, you'll get equal areas. The answer is supposed to be 2 to the 4/3, or you could write that as 2 times the cube root of 2.
So wait, I have a question.
Yeah.
So on the, oh wait, negative 2. Oh, okay, I was reading it wrong.
Sorry, I'm just writing. I was reading that one too. So these would need to be set equal to each other. Plug in your b's and solve for it. It's actually not the worst to solve for, because there's a lot of like terms that go together. But it is tedious. So. $8.30. Cool. Okay. Okay. For some reason, I felt like it's been longer. It hasn't been that long. What? Yeah. So number 9 is going to be next. Wait. I talked about this with the second recitation. We did this problem. Okay. So I'm going to breeze over it real quick. Okay. Yes.
So if we just left it as like the end part before the 3x minus x cubed over 3, like just to the left of that.
Yeah.
Would that be fine for the final answer?
Well, it's not really a final answer. The final answer, we find what B is. This is A1. I call this A1, and then this is A2. I'm waiting to find the B that will make those both.
Well, yeah, but like, would you have to fully substitute in the B's? Oh, okay, that's kind of annoying.
Yeah.
Yeah, kind
Okay, so let me talk through number 9 real quick. So or any questions and further questions here? Okay. Just plug it in work. I don't think you'd have one on the test like that just because it takes an abnormally long time to do. And
Then again, on this test, they have one about a cylindrical tank. That
Well,
probably
he's
take 40
making it
minutes.
multiple
do we number
choice, so he
17?
probably
Yeah.
doesn't do, like,
That was rough.
yeah.
Yeah, dude.
Hey, I thought I did a pretty good. I didn't think it was that bad,
Hardest
guys.
to like wrap my
I
head
mean, yeah,
around.
but like.
Yeah, no, I understand that. I agree with that. I think it's the
Yeah.
hardest one to wrap your head around. I
Once you
completely agree
explain
with
it, it's fine, but when I first looked at it, I was like, there's no way.
Even when you explained it,
Well,
it was like, I didn't understand how that.
There were also things
happened.
that we had to just know.
I was like, wow.
So I just.
Well, the things you had to just know are the things that he would give you.
Okay, I'm about to say, I was like, how do I
Like
just like.
force,
yeah.
force is mass times acceleration, the density, and like the acceleration itself he would give you. Like you're not
Pull out of my brain.
because you're not in physics yet. This isn't a physics class. I mean,
I could
this is a
not get
math
over the
class.
fact that the spot was on.
This- It looked like a little sun.
I could not get over that. I could not.
It looked like a little sun.
Tried so hard.
Okay.
Yes, it is. So I changed it to B when I did
I know it's not.
Okay, so number 9, yes.
Can you change it to B?
Yeah, I can change the
It makes more sense that way.
Yeah, well, that's true. I won't argue with that.
Yeah.
So this says to find, we're talking about average value, right? So the question just asks us to find a B value such that the average value of F over 0 to B is 10. Okay, so how do I find the average value of a function?
1 over B minus
Integral
Good, yeah, it's, yeah, right. Right, no, you're good. I just thought it was, I was expecting more of like, oh, you basically just take the integral and divide this, but it was like the exact equation, and I was like, oh, okay, great, wow, how about that?
Careful what you ask for, bud.
Yeah, well, it's so, yeah, a good way to think about the average value of the function is just think about, let me take the integral over the interval and then divide it by the size of that set interval, right? It's kind of like taking the mean, the mean value. But if I have 5 numbers and I add them together and I divide it, then it would be mean. So it's a similar thing in this case, but we're talking about it more in a everything's connected context rather than just like in pieces. So we need to, okay, so to set this up, F average, right? I'll write the equation down real quick. B minus A, integral from A to B of F of X dx. So then we replace it with B because it makes more sense. A would be 0 if we're going from 0 to B. So we're going to get 1 over B minus 0, which is B, times the integral from 0 to B of our function. And this is equal to 10. Okay. We need it to be equal to 10. We don't know the way I didn't know this thing was equal to 10, but I need to find what the B is that makes this equal to 10. Okay, so this integrates nicely, and then the B divides it, and so it's going to be just algebraic from there. Okay, do I need to work through it further? I heard a yes. Okay, I will. Let me talk a little bit more. I'll try to. We don't need to go all the way, I think, but I'll try to lead a little bit more into what we're doing.
Okay, so the our equations are different. My equation is 80 minus 34x plus 3x squared.
Yeah, that's right. I was thinking ahead. Because I know.
I was really
I saw what
confused.
you did there.
Wait, what?
I was like, you kind of went a little
I did
farther.
some of the integration already. That's my bad. I was thinking about it in the after integration and instead of
I
before
was like, we
integration.
kind of skipped some steps here.
Sorry. So we have this, right? Now, if I integrate this function, what do I get?
That.
So we get 80x minus 17 x squared plus x cubed, right?
Yeah.
Now you can see where I got where I got
Yeah,
it from.
well,
That's my
I
bad.
knew where you got it from. It was just like, that's not supposed to be there yet.
Okay, so there's an extra step of the integration, right? When we plug 0 in, everything goes away. Just so, and then when I put b in, we get 80b minus 17b squared plus b cubed. And this is all divided by b equals 10. Okay, so then we can divide a b from each, right? Does that make sense? I can. So then we're left with b squared minus 17b plus 80 equals 10, which is a quadratic equation. Okay. Do we need to, I don't think we need to relearn how to solve quadratic equations. Okay, cool. That one is factorable, by the way. So I know we had a discussion in the second recitation about how much we'll complete the square. So
Don't erase that yet.
okay, I will not. What? It's true. You have to
Why?
well, you have to basically it's because you're not just graphing, you have to graph like circles and ellipses and sort of thing. No, not in that context. No. Unfortunately not. You do have to learn to love complete the square at some
There's
point.
something else that I could do?
No.
Sorry,
I'm gonna erase it.
I can't remember.
It's gone. Okay, so we have 4 more. Cool, 4 more to go through. So let's see what these next 4 are. Because it seemed like everybody else was fine with the other few. Okay. Yeah, so I found this one a little weird to be here. Because it's not really calculus involved.
Which one?
I mean, it's a shape with volume, but it's not a circular shape. It's right, because so it says the height of a monument is 20 meters, right? And so we have some monument that's 20 meters tall, and it says a horizontal cross section at a distance x meters from the top is an equilateral triangle with side x over 4. Right? So what that means is that, so if this is the top, whenever I'm 20 meters away from the top, that means that I have an equilateral triangle with sides 20 over 4, which is what?
How, wait, what? If
I-
you're 20 meters from the top, you're at the bottom.
Yeah, right,
Then that's a straight line. That's a line.
right. Well, you have an equilateral triangle, right? The problem says that so if I'm 20 meters from the top, then I have an equilateral triangle
Oh, yeah.
with sides 20 over 4,
Oh, okay,
which is
yeah.
5. That's what the problem says.
It makes read the problem.
I'm not
I
just.
should read it like 3 times.
I'm not just making this a big problem.
Well,
So-
the 20 meters, it says on top is equal. it's
Yes, I
equal
promise.
outside X over 4 meters. The distance is X meters, so you're just putting 20
Okay,
divided by 4.
so this is, it's an equilateral triangle. What does it mean to be an equilateral triangle?
Oh, it's the same. Everything's the same.
Yes. All the sides are the same length, all the angles are the same. And all the angles in any equilateral triangle are always 60, 60, 60, 60. Okay, so. Yeah, I'll write that. Okay, now when I'm 16 meters away, what are my sides?
When you're what? 4.
16,
Oh, okay.
4. Or whenever I'm 12 meters away.
Oh, wait, is it just?
3.
3.
Oh,
When I'm 8 meters away.
2.
That's a little big.
Wait, is
That's
the
what it's called.
monument a giant triangle or is it one triangle with like a triangle?
And then when we're 4 meters away, it's 111. And then when we're at the top, it's just point. So
How do you not get that yet? Okay, I go down the line. Okay, let me explain. Okay,
they are all equilateral. The triangles going up are equilateral.
Oh, you see,
Yeah.
that makes sense after you draw it and reading this again. I still don't see how that.
That makes sense.
So it says, can I do number? I'll come back to it if we have time. Absolutely. Okay, so it says, so the height of the monument is 20 meters. It says a horizontal cross section, right? Is an equilateral triangle that whenever it's X distance away from the top, has a side length of X over 4, right?
So on the horizontal cross section, there is an equilateral triangle on top of that horizontal cross section.
No, the cross section is the equilateral triangle.
Yeah, that's not registering.
So
Isn't it cross section the entire triangle?
Which way is the cross section? Horizontal, it's just straight through, right?
yeah, it's just straight through.
Did
So
you draw that in 3D? The left one?
yeah, that's in 3D.
That's why, okay. I thought it was a triangles like this,
Yeah, that's.
but it's a 3D.
Yeah, I was trying to draw it. I was trying to draw in 3D because it's a 3D shape.
Oh!
Yes. That's why I was.
Yeah, I drew it in 3D.
I got it.
Yeah, I'm not gonna lie. I thought the monument was just a
That's
triangle.
okay, that makes sense, and
Okay,
reading this, I
I'm-
completely understand.
I am so sorry. Yes, this is in 3D. This is a 3D shape. I purposely because an equilateral triangle should be more like this, but I was drawing them like more like this because I was trying to make it 3D as I was going up. Sorry, I should have made that more clear. It's a 3D object, so I was making it 3D. I was making it 3D.
I was thinking.
Yeah. Imagine so as I cut through it, I'm gonna have a triangle at each level. Right? This is the triangle at 20, this is the triangle at 16, 12, 8, 4, 0. Okay. So I don't really know how to use calculus to solve this.
It doesn't say use calculus.
Exactly, it doesn't say it. I do know how to use geometry to solve this. The volume of this shape, which if he asked you to do this, you would be given it. I assure you, because I didn't remember it. Is going to be 1/3, and then we have this big B times H. Okay, big B in this case is represented by just whatever the area of the base triangle is. Okay. How do I find the area of this triangle?
Oh, it's base times height divided by 2.
So
5 times height.
So yeah, the base, we have the base and it's 5. So 1/2 base, which is 5. I don't have a height yet.
Oh, I see how he would want us to use calculus to find this.
What do you do?
Would you like to accept?
Because you're finding every triangle in between the 5 and the 0.
Yeah, or the 20 and the 0.
So that's how it's an integral problem.
Yeah, could you find the area? of the
But then you use.
Well, so the
Yeah, I'm a sigma.
That's it, I'm transferring to
I'm just switching my major altogether. I don't know. Business sounds great right now.
what does a cross section of this look like? Right? It's an equilateral triangle with sides X over 4, right? So yeah, so this is just like the tank problem.
Instead of a cylinder, it's a cone. It's a triangle.
Okay, so so we're gonna take one cross section and look at what's the area of that triangle. Okay.
And use that number.
Good, yeah, so how do I find that? So let's say we take a random triangle in the middle of it. Okay, I'm gonna draw this one upwards, okay, so this isn't 3D now, this is just a flat triangle, okay? And it has side x/4. Yeah, wait, down, x/4, right? How do I find the area of this
Good question.
triangle?
There's like lost signs or whatever.
No, we wouldn't have to use law of sines.
Oh, wait, you can just split it in half and then like find it.
Good. Yeah, let's do that. So I need to get the height of that triangle. So let's split it in half. So
Oh. X/8. No, plus B equals X/4.
so area is going to be 1/2 times x/4. How do I get the height? We haven't said the height yet.
No, it's.
Pythagorean theorem.
Yeah. So X/8 plus B equals
You're forgetting the squares. Pythagorean theorem says a squared plus b squared equals c squared. Wherein this is the 2 norm, not the 1 norm. So what we need to do is plug in, right? So what's going to be my a in this case? x/8. x/8 squared plus b squared is equal to x/4 quantity squared. Okay, so we're gonna get x squared over 64 plus b squared equals x squared over 16.
Why is it x/8?
Because we're only using half of the triangle. We're only using half of the base. We're
so
finding the
half-
height.
Okay.
Good. You can also, if you wanted to, we could use like sine of theta, sine of 60 is something over something, which could be easier depending on the context. We'll stick with Pythagorean theorem. So b squared is going to be x squared over 16 minus x squared over 64, which can I get a common denominator for that? So what's that going to turn into? 4x squared over 64 minus x squared over 64 is 3x squared over 64. Okay, so what's b going to be in that case? Yeah, so we have the square root of 3. I'll put that over here. Over 8. X over 8. Good. So x times the cube root of 3 over 8. Funny enough, if anybody remembers, this is a 60, 30, 90 triangle, so it actually has a standard this side's 1 times x over 8, this side's root 3 times x over 8, and this side's 2 times x over 8. That's okay. You don't have to. That's the nice thing about this. You don't have to remember. Okay, so that is, I guess I should have wrote this as height instead, but this is our, so just not to confuse anybody, this is H. So that's our height, right? So then I just put that, I multiply that here. Okay. And so that's going to be 4 times 2 is 8. 8 times 8 is 64. So we get x squared root 3 over 64. Cool. Okay, so that is the area of one triangle in between, depending, no matter how far from at the top you are. Okay. So I need to add up a whole bunch of triangles. So what's the last step here? Integrate from 0 to 20. We still need to go to 20. We need the full length of x squared root 3 over 64 dx.
But don't you need to do the equation?
What?
Because it gets smaller as it goes up.
The what equation? Well, this isn't a cone. This is like a pyramid.
Yeah.
Well, we started off with that, but we want to do this using calculus, then we just found a way to do it. That's why we just did what we did.
Oh.
Because we found the area.
The equation is the area.
Yeah,
Okay.
this is the area. So I'm taking the area and then multiplying it by dx, which is like the height, basically the width of each point, if you remember the water tank problem. And so we're adding up all of those, triangles, okay? There's a big theme here of adding up pieces, okay? If you don't know how to get the whole thing, just break it up into pieces. There's actually a whole, for you engineers who plan to go into the grad classes or well, it's not, I mean, you can take it at your undergrad. It's actually extremely valuable though. It's called finite element analysis. That's all about just like breaking things into little bitty pieces and to approximate things rather than.
Is it hard?
Huh?
Is that hard?
Not really.
That's for engineering.
Not really. It's actually not that bad. If I said it was hard, it was because I took it over the summer and so it was a lot at once. But it's really not that hard. So it might be something to look into. I mean, it would be something you more use in your daily life rather than some of this.
Unrelated but related. How long are some of the classes?
They're shorter. They get fit in a span of what is that? Basically 7 weeks, 8
Yeah.
weeks.
So it's kind of, they kind of have to like clean the material a little bit more.
Yeah.
Mm-hmm.
Is this? Do I need to finish this through? Is this good?
You might want to.
Yeah, you finish it.
Yeah. Don't listen to Carson. You can finish.
Wait, you just plug in. Nope.
Just
Wait. No. Yeah.
Yes.
Oh, no, you don't. Never mind.
So
What I was saying.
the cube root and the 64 are just constants. So I'm just going to set them off to the side. So then I just integrated x squared, which is 1/3 x cubed. Okay. And you have to do 20 cubed, which is a little work. But it will end up being whatever the answer is. Yeah, I got you. It should be 8,000, I think. Because it's you do 2 cubed and then multiply that by 1,000.
Yeah.
Cool. Okay, that is number 13. Okay. 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 I'm gonna address 15. I'm not gonna work through 15. I'm please like I'm not gonna go.
You think
Oh,
15?
no.
Do you think something like 15 would be on the?
No. No.
Okay, I'm gonna write not on.
It's like that's alpha like minus L.
Okay, so how do I find the work done on a spring? So the force on a spring is Kx, right?
So then would you do the work is the integral from, I know it's a minus L to b minus L kx dx. And then what you equal 1 to 132, 1 to 588, and that's literally as far as we got.
Right. So this is so L in this case is my natural length. Okay. So I take, if I'm some a distance, then I'm going to use the distance from from the natural length. You don't use a itself because you won't get the right. You're not going to get the right value, right? Because whenever the spring is at rest, that's like there's nothing happening to it. It's an equilibrium. So there's no work being done to it. It's only the distance you stretch from the spring that things start to change and happen. Okay? Yeah. What is it? This? No, this is for stretching it. Right? Because, so let's say that the natural length is 5. Okay, and I want to stretch it from 8 centimeters to 13 centimeters. Then I do 8 minus 5, which is 3, and 13 minus 5, which would be 8. So then I have to go from 3 to 8 instead. Okay, it's still stretching it, but you consider that the natural length is the equilibrium point. Okay, so yes, so what I wrote down was this, and this was equal to, what is that, 132 joules? So it says that going from one length to another would be 132 joules of work. Okay, and the what is it was A is it was 0.09, 0.12, because it's 9 centimeters and 12 centimeters. Okay, whenever we're talking about force, you always want to try to use things in meters. You always want to try to put things in meters. don't try to use centimeters unless for some reason like whatever you're given and the distance match up in the units. Generally, it's easier to change everything to meters because you know that you're in safe territory. Okay, so that's why I have 0.09 and 0.12 here. Okay, the second one, you would do the same thing, right? But then but now it says to go from 0.12 to 0.19. What is it, 19 centimeters? Anybody? Oh, looks like everybody tuned out.
Sorry, you said not on the test.
Yeah. It's
Wait, what are you, wait,
That doesn't mean you don't want to understand the concept. That's why I'm covering it in the first place.
Physics?
Huh?
Mechanics?
Yeah,
Okay.
I'm not, just because the exact problem won't be on the test doesn't mean, that's like saying an example I do in class isn't gonna be on the test, so you just can ignore it.
That's not what it sounded like. It made it sound like nothing remotely like this is gonna be on the test.
Nothing exactly like this problem will be on the test. Will there be a spring problem on the test?
yeah.
Probably,
We went over a couple spring problems, I think.
yeah,
Yeah.
Just not like that. It was. Yeah. the-
Okay.
Yeah.
everything I've written here is just information from the problem. Okay. Nothing that I've written down here is anything new. This is information that was given in the problem, okay? L is the natural length that we don't know. And K is the spring constant that we also happen to not know, which is unfortunate. Because that's really what makes the problem hard.
So like on a problem on a test, like we get either like one of those.
I'm sure you would only get one and then you would get K and then you would solve for it. Or you might not have K and you need to find it
Okay.
from having L.
Okay.
You wouldn't not have both.
Both of them.
Because this is a bit extreme to have to find both, because I mean, it's possible like with algebra, but it's just a hassle. It's a hassle to do it. But we can integrate this, and then it's going to be similar to the problem with the b's, you know, with the y equals b, where you have to kind of set the two things you get equal to each, actually not equal to each other, sorry. What am I trying to say? So what's the integral of kx? K is a constant. What's the integral of kx? 1/2 kx squared. Good. So I would evaluate the top one from 0.09 minus L to 0.12 minus L, and that would be equal to 132 joules. For the second one, it would be the same integral because it's the same function, but instead I would evaluate it from 0.12 minus L to 0.19 minus L, and that would be 588.
Will they give us the spring?
I'm telling you, if you have one like this, they would either give you the spring constant or give you the natural length. Okay, because what this is, after you evaluate it, it's a system of equations. You have two equations with two unknowns in them. You don't know the length and you don't know the spring constant. And so then you have to do the work of, well, let's solve for L and let's solve for K. But like I said, since K and L would end up multiplying at some point, the equations aren't as simple as substitution or elimination. They could be, but it would just be nasty. So, okay. So let me make a quick suggestion here. And let's say that let's say that I was given that the spring constant is 200 Newton meters. Okay. When I integrate this, what would I get? Good. And then I would evaluate this from 0.09 minus L to 0.12 minus L. Which would, so I'd get 100 times 0.12 minus L squared minus 0.09 minus L squared. And then whatever, oh my God, that's first. And whatever this is, it would be equal to 132. Okay. Would you be able to find L in that case?
Yes.
Right. Well, it shouldn't be too bad because the L squareds are going to cancel out. So it's just right, because you're going to get, so you get 0.12 squared minus 0.24 L. Right, everything would get multiplied by 102, so it would actually be pretty simple. Plus L squared minus whatever this thing is, so it's gonna be minus 0.09 squared, plus 0.18 L, and then minus L squared, right? So even the quadratic part would go away, because the L squareds would get canceled. So you could solve for L and it wouldn't be that bad, okay? The decimals are, but that's an easy problem, right? And this, let's now, in the same way, let's think about if I was given, I didn't know K, but I knew that L was 0.09. Sure, why not? Well, then you would put L, right? And you would subtract L from the two values you're integrating from. So then we would instead get 0.03 of kx dx equals 132, right? And it was, again, what's the integral of kx? So we get 1/2 kx squared from 0 to 0.03, which would be 1/2 k times 0.03 squared, because the 0 doesn't matter, right? And this would be equal to 132. Can I solve this for k? Yeah, that's not bad, okay? It all starts from this basic point, right? But if you're given one or the other, the problem really isn't that bad. It might take a bit of work, but it's not that much of a hassle, okay? So I would expect that and not as much of both of them not being known, okay? I gave one actually on the study guide that's similar to this one. So whenever you guys start working on that beast, I know some of you guys have looked at it, but there's a toaster. There's a toaster.
There's a toaster.
In
toaster.
draw.
No, not just a toaster.
Yeah.
It's a Mickey Mouse toaster.
That's what makes it.
It burns Mickey Mouse heads on the side of your toast. I'll be honest, I got a new toaster at my house and I was like, well, it'll be a fun prize, so. Okay.
I won, but what price?
Does that mean you had
We
to
put it in
do
the, we put it in the door.
What?
Does that mean you had to do it before you said it?
So it's a used toaster.
It's a good toaster though.
Oh, wait, I can't even have that in my dorm room. It's the fire.
No,
hazard.
it doesn't matter because if you already say, you just have to tell them the way to say.
Oh, yeah,
it.
you're
And you
still-
either make the toast or give it to them. and-
I wanted to do something fun and I didn't want to be like have a cash prize or something for it, because I feel like it'd be weird, I don't feel like that's something you should do to be like giving cash out to students or something for doing that, so. Okay. 16, I skipped over 16, oopsies. Okay, let's go back to that. Yes, we talked about this in the morning one. I'm gonna address it. So we have a tower that is 110 feet tall. I'm gonna tell you that 110 feet actually doesn't matter. It's simply there. It's simply there to affirm for us that, yeah, so this is 16, I'll write this up here. It's simply there, yeah, that it's completely hanging, it's not on the ground. Okay, and so I have this rope that's hanging down and it's 40 feet long. And it weighs 0.8 pounds per feet, right? Now, each time I pull a foot up here, I'm gonna lose 0.8 pounds of weight, right? Because it's not, I'm gonna lose that weight I have to pull up after I get it up here, right? So if just the rope as it is, if I'm hanging it off the side, how much is that gonna weigh? How do I find that?
Would it be like
Oh,
40 minus 0.8x?
So you're on the right track, but we don't want to use 40. We need to use whatever the weight is initially.
So 40 times 0.8.
So we find 40 times 0.8 first. Okay, so this is 32. Because 0.8 is the same thing as 4/5, because you can do 8/10 and then change that to 4/5, and then you would get 32 from that. Okay, so that is the initial weight of the rope. Okay, and as we said, each foot that you draw up the rope, you lose 0.8 pounds. So as you said, 0.8, we have minus 0.8.
The 32 minus 0.8.
Good. Okay. And so now we need to add this, we're thinking about little segments again as we're going up. So that's where my dx comes in. And now I integrate this from what to what? 0 to 40.
Oh, this one was easy.
And so that's it. Yeah. It's the setup. The setup's a little, yeah, no. See, yeah. Does this make sense? Is this good?
Yeah.
Okay. You really just need to think about what's happening in the problem, right? You want to think about, okay, well, as I pull up the rope a little bit, I'm going to be losing some of that weight, right? It's a lot less I have to carry up. So that you would integrate this and then you would get a value out of it. Cool. Okay, so the last one that we had on the board, I was also asked to do number 11. I kind of want to see what number 11 is real quick. Oh, okay, it's a volume problem. Yeah, I'll come back to that at the end. Okay, so number 18. Personally, I think is probably the hardest one to visualize, but and I'm not quite sure if the answer in the answer key is right either. Because it says the answer key says it's 36, but you definitely have a circular disc, so it shouldn't be a whole number. You should have pi involved in some way, shape, or form. But regardless, we're gonna work through this. So let's talk about what it says, right? We have a circular base. Okay, so I'll draw a base. It's 3D. I'm drawing this in 3D. Let me go and say that. I'll do that. This is in 3D. I'm not just drawing a circle. Okay. Now it says find the volume of the solid if parallel cross sections perpendicular to the base are isosceles right triangles with hypotenuse laying along the base.
That'd be like 10 minutes of the test right there. It's me reading that. Trying to figure out what that means.
Okay, so we have parallel. So it's first it says parallel cross section, right? Which means that if you cut we're just cutting along the line, and we're gonna see this shape as we go along. Okay. The next thing is it says that it's perpendicular to the base, right? So that means that we're not cutting the circle necessarily. We're not cutting through this, we're cutting perpendicular. Okay, so that's our cross section. Okay, so our cross sections are coming up from it. Okay. Third, it says that they're isosceles right triangles. What does it mean to be an isosceles right triangle? What is it?
If we're cutting it this way, is it talking about like drawing it, like, is that the base?
That's the base.
So is it talking about like the triangles and you're cutting through here, it's gonna be like keeps down the line to be like this?
Yeah, it's gonna be something like that. Okay. So what does isosceles mean?
It has two sides of the same length.
Two sides of the same length. Okay. And then there's a right angle, right? So the hypotenuse has to be longer than the two sides, but the two sides have the same length. Okay. So we're looking at something that, and it says that the hypotenuse is on the base, right?
Yeah.
So
Along the.
Oh, so it's like this.
good. It's a cone, right?
They use all of that wordage just for that.
Yeah.
It's for concept, man.
So it's a cone shape. I drew it a little, I messed up a little on the end there, but you can see little triangles building up and little triangles building back down. But we have it's a cone, right? Because it has a fiddle on the circular base as well. So we have a circular shape, right? So now we can turn this, we don't have to necessarily work at this like we did the triangle monument, but we can look at this like the rotation, the volume of solid, right? So let's think about that. So that circular base is going to come once I rotate it, right? But overall, I want to look at kind of the biggest side out here, right? That's kind of going to be the main outside point that I'm flipping around. And so I'm going to it's going to look something like this, right? And so if I take this region and I rotate it, is that gonna give me the shape I want? Yes, it will. Okay. So I need to find the equation of that thing, right? Remind me, what's the radius of the base?
3.
3. Okay. So the interesting thing, so this is an isosceles right triangle, right? So that actually, what that means for us is that there's actually only one option for the angles on the inside, right? Because if this is 90 here, and these sides are both the same thing, I'll call them A, 45. This has to be 45. Okay, so this angle here is also 45 degrees.
Can you say that again, why you know that there's a right angle in the triangle?
Because that was given the problem. It's an isosceles right triangle.
Oh.
And the hypotenuse is on the bottom. So the right angle has to be across from it. It's also going to be 3. Yep. So you can see that probably just geometry wise, it has to be the same size since it's 45, 45, 90. You could also just set up a trig relationship, say tangent of 45 degrees is opposite over adjacent, which that means that x has to still be 3 because tangent of 45 is 1. So either way, that's going to be 3. Okay. So we have the point 3, 0 and the point 0, 3. Can I find the equation of that line?
Yeah.
Y equals 3x.
No, x plus 3.
3 minus x. You're very close.
Yeah.
So let me go through that real quick. The reason why, so we have to find the slope, which is going to be y2 minus y1 over x2 minus x1, which would be minus 1. And then we have a y-intercept. Our y-intercept is 0, 3, right? We don't have to bother with using point slope if we don't want to, right? So our equation simply becomes y equals negative x, negative 1x. Okay. So we're talking now, we see clearly that we have the region bounded by y equals 0, x equals 0, and negative x plus 3. And I want to rotate this about the y-axis. Okay, or well, it actually would be the same size. Depending on how you draw it, you could try to turn it into disk as well. I think it's easier based on what we're trying to imagine with our shape that we can just do shell. So let's think about this as shell, right? Well, which way is the rectangle we're gonna go first? So it's gonna be up and down. Good. I don't know if that was clear. Sorry, I misspeak sometimes. So there we go. So the rectangle has to be up and down again because this is a function of x, and so we need dx. Okay. And since we're parallel to the axis we're rotating around, what method? Shell. We need shell method. Good. So I need 2 things for shell method: a radius and height. This is probably the easiest shell problem you can get, actually. What's the radius going to be?
Oh.
X. The radius of this whole base is 3. We're talking about the radius as you change as it goes through. So you need to use 3 or x. Sorry. What's the height going to be?
3.
Negative x
Oh
plus
my
3.
God.
What?
Why is the height equal, like the
So we're talking about the height of the rectangle,
yeah.
right? So what is y at this point?
The height is always changing.
Right. So it has to be the line, right? Okay.
This should be a completely different.
So now we're gonna take the integral from what to what? 0 to 3 of x times minus x plus 3 dx, and then multiply that by 2. Good, great. I'm glad to see. Yeah. Okay. I can evaluate this real quick. It shouldn't be too bad. So we're gonna get 2 pi This is gonna be minus x squared plus 3x. So we're gonna get negative 1/3 x cubed plus 3/2 x squared from 0 to 3. And so we get 3 cubed. So that 0 doesn't do anything. 3 cubed, or 3 is gonna be 3 squared, which is 9. So we have 2 pi times negative 9 plus what is that gonna be? 3 squared 9, that times 3 is 27. 27.5. And so I can write this as minus 18/2. So we get 2 pi times 9/2. 9. Which is, I mean, if you for some reason like to round pi to 4, I guess you would get 36 out of that, but yeah.
I think we just do like sideways rectangles with y.
Why not?
Oh, it does? Okay.
Yeah, it works too. And then you can do washer. Well, actually, it'd be disk in that case because there's no. This is like the best possible example of a disk or shell problem because there's no space between. It's just you'd only have to use disk and shell the height would literally just be the function. Okay. So I was asked to go through number 11, so I'm gonna do that. But we have finished the current list. If anybody has other questions or just a really something that they're just not understanding that like I might need to communicate, but with that should be a good summary there. So let me go ahead and do number 11 for those who are heading out. Thank you for stopping by. Okay, so we want to find the volume of the solid that's obtained by rotating around the region bounded by y equals x squared, y equals 0, x equals 1, and x equals 8. And we want to rotate this about x is minus 1. Okay, so let's draw the curves, right? This is, I mean,
Since. Never mind. Wait, just try. Since we're not rotating around the x or the y axis, is it a washer
It's about
or a
one.
shell?
well, we'll see, right? Let's draw it and we'll figure it out from there. Okay, always draw the picture first and then decide from there.
It's about just one.
Yeah, just one.
Okay, thank you. I thought something was finishing. Okay, so so we have x squared, which is that'll have both sides. Y equals 0, x equals 1, and x equals 8. So I'm gonna fix my picture slightly so I can try to fit that in there. Okay, so this is 1 and this is 8 over here. So we're talking about this region. And I need to rotate this about the line x equals 1. Or x equals 1, right? Okay, cool. So which way should I draw my rectangle? Up and down.
So
We're gonna use shell because it's parallel to the axis. Okay, even if we're not flipping around the y-axis, we're still flipping around a line that's parallel to the y-axis. And since our rectangle is parallel, we're gonna.
and it's gonna be dx.
Yes. Okay, so we need two things for shell again, right? So I need a radius and I need a height. So this is the radius for these problems is where I think shell, can be maybe a bit more interesting, right? So what is the radius for this problem going to be? X is right.
X minus 1.
X minus 1.
Yeah.
Okay, so the reason being is because again, I want to say, okay, let me say I'm some distance away from the y-axis, okay? And which is x, okay? And then I want to see, well, what's the radius from my axis that I'm actually rotating around? Well, that would be however much x distance I've gone minus 1, right? So if I'm out, if x is 3, then my radius at that point would only be 2, because I'm only 2 from the 1. Yeah.
Okay, so if a graph is rotating about a line that is not bound by, then is it washer?
What is it? You remember that I drew the rectangles and that's how you determine which one?
No, like between washer and disk, like.
Yeah, so okay, so here's okay, let me show you.
I think I know.
Yeah, I
I'm
think
trying to-
washer's just more,
They're pretty much the same. I
All
just
of them
wanna
are
know
the
which,
same, but
this is like the easiest one. Right.
I think Chelsea's just not.
So.
Yeah. That's
Okay, yeah, that's what I was, okay.
This one you'd only need to use disk. This one you would have to use washer.
Okay, because the left one's bound by the axis.
Because this one's next to the axis itself. This one is not. There's white space in between. If there's white space in between, then you're gonna need to use washer. Yeah.
Then the radius there is just to move x such that it starts at the axis of rotation.
Yeah. Good, yeah. So you're taking an x value and you're saying, okay, where do I need to position this? So I can get a distance from the 1 instead of from the axis itself. Okay, so what's the height gonna be? This one's x squared, yeah. R is x minus 1, height is x squared. So then what's the volume gonna be? How do I find that?
Integral.
So we're gonna do an integral. Yep.
2 pi.
So yeah, so we're gonna have the 2 pi, which you can put that inside or outside. It's a constant. It doesn't.
So there's 2 pi for every single one of the methods.
Only so 2 pi for shell, pi for disk and washer.
Okay.
Okay. And the reason being is because shells are literally built upon shells, right? To find whenever you're finding the area of the outside of a cylinder, it's 2 pi RH, right? And that's what the shell method is. And so that's why the 2 pi is there. Whenever you're finding disk and washer, it's based off of circles. And the area of a circle is pi r squared. So that's why it's pi in that sense. Okay. So one sense it's adding cylinders, the other sense it's adding circles. So that's why it's 2 pi in one and pi in the
So
other.
it's like 2 different circles.
Basically. No. What is, so this says find the area of the region bounded by the curve.
Okay, so.
And this one
only
says
for
find the
volume.
volume, right? And now, oh man, my internet connection's unstable. Okay, well, hopefully I'll try to finish this one. But yeah, if it's volume and it's a surface of rotation, then you're gonna be doing one of these, right? We did the triangle one, and that wasn't a surface of rotation. And so that volume was a little different, okay? But so just remember kind of what the context is that you're working with.
So that's only for rotating objects.
Yeah, so these methods are purely for taking a shape and rotating it around. So it gives it a circular object, a shape of some
So
sort.
if it's not rotating, it's just like that geometry stuff.
Yes. Good. So 2 pi from what to what? What? Not 0 to 8, 1 to 8, right? Because we're bounded by 1. Okay. Yeah, it hopefully it's not 0 to 8 because that gets into some weird situations, because if you're flipping around this line and it includes 0, then you're gonna get things that overlap, but you wouldn't have that because it's a silly thing to run into. So we're gonna have r, which is x minus 1 times x squared dx. And that is the answer.
What about 1 minus x?
1 minus x. So let's think about that. Why isn't it 1 minus x? Okay, so what would 1 minus x say? 1 minus x would say, okay, so I go out a distance of 1 on the y-axis, and then I subtract off each x values. So is that putting me over here, or is that putting me over here? When x is 2, what's 1 minus 2? Minus 1. So that puts me here. That's not inside my shape, that's away from my shape.
Okay.
Right? So it has to be x minus 1, because that's going to give me values, that's going to put me inside the actual shape, right?
So it doesn't matter if the graph is like on the left side of the y-axis, it's the same thing.
Well, if it's on, if what you're doing is on the left side, then it would be the 1 minus x situation, right? 1 minus x puts you over here. X minus 1 puts you on this side.
Okay.
It's like getting to the,
Right.
So it's like
like
shifting
from the
it,
line.
Right.
yes. So the minus is shifting to the right.
Yeah. I wrote an equation, at least for the morning. I'll do it here as well. Which is r equals radius is axis. I'll just write axis here minus number of I'll just put axis of rotation, AOR. Okay, so this is a general equation that does capture everything. And it says, see what direction you're going, right? So if this is dx, then this is going to be x. If this is dy, then this is going to be y. Okay, so this is either x or y. It's going to be one of the two. Then this is, you see where you're flipping around, and then that's going to be the number of that thing, right? So in this case, it's 1. It could be 2, or it could be 3, it could be 0, right? But that goes here, right? Now the absolute value is crucial because it was what I was just saying. If I did 1 minus x here, that's going to give me negative values because my x's are supposed to go from 1 to 8. And I don't want negative values, I want positive values, right? So that's why this has to be x minus 1. Now, if I was on this side, then then the negative values would give me positive values, right? Because I would be getting 1 minus x, you'd be 1 minus 0, 1 minus negative 1, 1 minus negative 2. It's positive. It's a positive distance. Okay, so I don't like to think about it in this way. I mean, you could always write this down and find it using that, just kind of by seeing when it's positive, when it's negative. I think it's better more just to look at the graph and kind of understand. First, what variable am I using? Second, what's going to give me the distance, the positive distance from the axis I'm rotating around? Okay, cool. So that's number 11. Okay, cool. I guess that's all of those. Anything else here? Spring compression. That would be L minus. Right? Because when you too. Thank you. Whenever we're doing most of the problems of stretching, again, it comes back to this positive distance idea, right? If I'm stretching it, I need to get a positive distance. I need that to be positive, right? So, but I'm stretching it from the natural length. So I take the bigger number minus that natural length. If I'm compressing the spring, then I still need to be measuring I need to be measuring those distances. Actually, I'm trying to think with that. Actually, yeah, maybe it would be the same. You might just go, I think you would just go to negative values instead. Actually, now that I think about it, I think you would still do minus L. Because the work is just going the opposite direction. So in a sense, it would just change the value. I guess, sorry, I was thinking for some reason that I have my mind all caught up in here, so.
I missed when you went over 5.
Miss whatever 5?
Yeah.
Yeah.
Yeah. Oh, no.
Yeah. So, okay.
You don't
don't listen to them. It's not that bad.
Okay, did you guys already do it?
Yeah,
And like, just take a picture at least?
It's not worth the time.
I recorded it on here, so I can post it. And you can look at it again if you want.
I'm not in your recitation.
That's fine. I'm gonna send it to everybody.
Like the whole recording?
Yeah,
Okay.
I'm gonna post it on YouTube. So,
Okay.
because there was another student from another recitation that asked if he could watch it too. So I'm just gonna send it to all people and kind of let them know that we did a study session about it. So,
Okay, and it'll be posted.
Yeah.
In like a little bit.
yeah, as soon as possible. It takes a bit for the video to process on Zoom, but
Oh, that one. I thought you meant the tower one. Oh, my goodness.
all right. Yes. What is it? 17? Yeah, absolutely. Yeah, you too. See ya.
You guys went over 17?
That one.
Oh, is it the tank?
Yeah.
Okay, so I'm gonna record this. So you guys don't, yeah, I know for some of you have seen it. If you want to stick around, you can. I know there's probably a lot of people in the recitations that might want to see this. So I will.
I don't see how anybody else could like figure that out.
You think that's gonna be like a bonus question or just like?
There's no way we have time to do that. Yeah, no, seriously.
The hardest part of it was the volume. I think the biggest thing is to try to understand what's happening in the problem, and that'll make it a little better. There's just a bit of geometric work. I don't think it's really like the hardest thing, but I do agree that there's a bit more of it's applied in a different context than you expect. So, okay, cool. Number 17. I think this is the fourth time I've done this problem today. So
You love that problem, yeah.
yeah, I would say I know this. I have to know this problem pretty well at this point. Okay, so I have a tank of water. How'd you find out about this, by the way? Just curious.
I was over there and then that one chick, because he walked by, I was like, hey, where did he go? Because I know him. And then he's like, oh yeah, he's in this room. So then I just went here.
Oh, okay.
I'm
Yeah,
so
you.
confused.
Oh, did Alexis?
Yeah, you walked by right when I came in.
Yeah, I don't know. I was expecting like there's people from our station there. So anyway,
They're tired.
You guys like motorsports? You like motorsports? How's the club? Are
Oh my.
you in the club?
Do not get me
okay,
started.
so I'm drawing this picture here. This is just information given the problem. And this says that we have a tank that's 5 meters long. We have a radius of 2 meters for the circle, and the spout is 2 meters above the tank itself. Okay, the problem says, and I'll probably do this more. I apparently the practice test says to actually call this x equals 0. I personally like to usually do it as y just because it makes more sense going up and down, but it doesn't matter in the end. It's a dummy variable nonetheless. So what we need to do here in this problem is a couple things. We're wanting to find work, right? What 2 things do I need for work? Need a force,
Distance.
and a distance. So we need a force and we need a distance. Okay, to get the force, okay, you would be given this. When it came to this, if I'm sure, but just in case something weird does happen, in this problem, or in most cases, if they don't give you some sort of force equation, if you're not dealing with the spring, force is going to be represented by mass times acceleration. Okay, where mass is ignoring gravity, it's just how much basically stuff you have like on you essentially. And acceleration is just how much you're, like when you're accelerating a car, it's just how much you're increasing in that case, right? So we don't have a mass value, but that's okay. We could, because we're going to kind of see as we go through this problem that things are going to be changing throughout. Okay, so but I know a density. The density of water you may know, or it should be given to you. I'm gonna represent by rho is 1,000 kilograms per meter cubed. Okay, so that's saying if I have 1 meter cubed of water, then it weighs about 1,000. It weighs 1,000 kilograms. Okay, if I want to know how much mass I have, right? Given it's 1,000 kilograms per meters cubed, what do I need to multiply the density by to get that mass, to get the kilograms? Was it? By volume, right? Because this is meters cubed.
Yeah.
If I multiply 1 over meters cubed by meters cubed, it just gives me whatever it is. So my force, and I guess I'll mention too, we're talking about gravity. Acceleration is the thing that gives us the gravity, right? Which in this case is generally should be 9.81-ish, but we're gonna call it 10.
That's gonna be like down the final probably.
Yeah.
Okay.
Yeah, it would say probably what to approximate it to as well. So you know what to do, not just like kind of doing it freely. But I'm gonna put all this stuff in here, right? So force ends up being my rho times of volume, which I don't know yet, times acceleration, okay? And since rho is 1,000 kilograms per meters cubed, and acceleration is 10 meters per second squared, what's 1,000 times 10? 10,000. Times v. Okay, and then there's units on this. It could be newtons and such, but this is force. We don't know the volume yet, but this is the force just based on whatever the volume is. So the volume is 3, then the force is going to be 30,000. Okay, cool. Let's talk about distance real fast, because this won't take much. So what we want to imagine is I have a certain water level in my tank. Okay, we said x is 0 is here. This is the base level, and let's say I have water up to here. Okay, so that is a distance x up from the center. So how far does the water have to travel from this point to get to the spout?
From the water up to the top of that thing?
Yeah.
Is that 2 meters? Or is it like?
Yeah, that's so the radius is 2 meters and the spout is 2 meters.
Is it just,
X isn't 2 meters, but
so is it 2 meters plus X?
not 2 meters plus X. Because that would give us, that wouldn't put us all the way at the spout. Right. And that's not exactly covering the distance we're looking for. So what's the total distance from the center to the spout? It's 4, because the radius of the circle is 2 plus 2, which is 4. Right? So the total distance is 4. And since I'm in X amount up, then I have to figure out what this space is, which is going to be that 4 minus X. Okay? So we get 4 minus X. Does that make sense? We good there?
No.
Yeah.
No? That's not good. Okay. So if this is X, right? So let's think, I'll write it on this side. So if this whole distance is 4 and this distance is X, how do I find this distance?
Okay. Yeah.
It's 4 minus X, right?
Yeah.
So that's where that comes from. Okay, so if I'm X up and I go 4 minus X up more, it's going to be 4. Okay, so we have force is 10,000 V and D is 4 minus X. So first we're going to need to know what that V is, right? And also I'm at a point, if I multiply my force and my distance, I have this X going here and I need to do something with that. It needs to be added in some way or changed, right? So I'm going to go to my volume to help with that. So whenever we're finding the area under a curve, right, I take it and I slice it into bits, right? I have rectangles at each point. And so each of those rectangles have a specific width to them. And so I add up all of those rectangles and I approximate the area. Of course, if I do an infinite amount of those, then I'm going to get what the area is. We're going to do a similar thing in this case, except instead of just simply an area, we're talking about volume. And since we're kind of working in this direction, right, I kind of want my dx to be here. I'm going to do a horizontal slice. So it's going to be, so I'm going to get a slice that looks something like this. I'll try to draw 3D so you can see it a little better. Okay, so I well, it's just a little far out. So I just cut like a little rectangular sheet out. Okay, does that make sense? I'm going to add it up. Okay, so I'm taking this volume and I'm kind of putting it into little slices. Okay, so what do we think that the height of this little rectangle is going to be? What do we think? Right, so we sliced it this direction. So we're wanting these slices to be as small as possible, right? But we want them all to have the same width. So that is going to be my delta x, or that'll be, I'll call it dx. Okay, because I just want to immediately make it like small. Okay, so that's dx. What's the length of each of those rectangular sheets? Like this. Yeah, good. 5 meters. So that's taken care of. Good. The width here is going to be the thing that's the hardest. Okay. So to help us look at it, don't be afraid to draw more pictures. We're going to draw another picture. Okay. So let's say here's my rectangular sheet that I cut out. Here's the center of the circle where I have x is 0. Okay. And let's suppose that I am an x distance above the center. Okay. I need to figure out what the width of this thing is, right? And so to do that, I need to be able to figure out, what I want to be able to put everything in terms of x. So I can't just name this something else. I need to put it in terms of x somehow. So remind me, what's the radius of the circle? It's 2, right? So if the radius is 2, that means that no matter where I go from the center, I'm going to have a length of 2, right? Most importantly, or more specifically in this case, that distance is 2 meters, correct? Right, because I'm going from the center up to the side, which would be 2 meters. Okay. So if this distance is x and this distance is 2, can I figure out what the length of this side is?
Yeah.
Why is that?
Right triangle.
So right triangle.
Right triangle.
Good. So we can use Pythagorean theorem. So Pythagorean theorem says that, so I'll call this, I guess I'll call this z. I don't want to use y, so we'll just use z. Okay, so what does Pythagorean say in this case? Pythagorean theorem say in this case?
X plus z is equals to x squared plus z squared equals to 2 squared.
X squared plus z squared is equal to 2. What I said earlier, it's not this is a norm 1 space, it's a norm 2. So you guys don't have to worry about that. So x squared plus z squared is 4, right? Can I solve for z? Can I solve this equation for z? Yeah.
Yeah, I guess. Do set that.
So we subtract x squared and we take square root.
So it'd be 2 minus z. I mean 2 minus x.
So remember,
Under the square root.
the square root of x plus y is not the same thing as the square root of x plus the square root of y. Right? A major example of this is that if I take the square root of 9 plus 16, this is not equal to the square root of 9 plus the square root of 16. What's the square root of, what's 9 plus 16? Square root of 25. What's the square root of 9? It's the square root of 4. Is 3 plus 4 equal to 5?
No.
No. So you cannot take the square root of the sum. Okay. The only thing you can do is just leave it as it is. So we're going to get 4 minus x. Okay. So be careful. Be careful with that. Make sure that's because anytime you're taking something to a power, it's not simply just the powers to each piece. Certain contexts it might work, but not in general. So this length z, and that's just this piece, is equal to 4 square root of 4 minus x squared. So how can I find the length of the whole thing? Yeah, well, you'd add them together, which they're the same length, right? So you just double it. So that means I'm gonna write our things here. So the length of our rectangles is 5. The width of our rectangles is gonna be 2 times the square root of 4 minus x squared. And the height of our rectangles is gonna be dx. Okay? So what's the volume gonna be? How do I find the volume from that?
Multiplying the lengths, the width, and the height.
Good. So 5 times 2 times this times dx, which will be 10 times the square root of 4 minus x squared dx. Okay, we're almost done. So force is going to be 10,000 times the volume, which is going to be 10,000 times this. What's 10,000 times 10? 100,000. Good. So force is going to be 100,000 times, oh, sorry, forgot a 0. Times the square root of 4 minus x squared dx. Okay. How do I get work again? Force times distance. And I'm adding up, right? Once again, I have this dx, right? So I'm adding up each of these rectangular areas until I get the whole shape. So I'm going to be doing an integral. What do you think that, so we're going to empty out the whole tank. So what do you think the integral is going to be from? What is it?
0 to 5.
Not 0 to 5. So remember the radius of this circle is 2, right? We said the center is x is 0. So I want to take everything from the bottom of the tank to the top of the tank. At what value is this at the bottom?
0.
No, this is 0.
Oh, so it's
-2.
-2.
-2. So this is x is -2. What's the value at the top?
2.
X is 2. Okay, we don't include the spout because the spout isn't part of the tank. It's just empty. It's you empty the tank with it. Okay, so work is going to be the integral from the bottom of the tank -2 to the top of the tank 2 to empty it all out of the force. So it is going to be 100,000 times the square root 4 minus x squared. I'll put the dx on the end just because that needs to be on the end of the integral anyway. Times d, which is and therefore that will be the answer.
So on the final, we don't really need to even like solve it. We just set it up like.
Yeah, just set it up. Even the problem on there just says to set it up.
Oh, for real.
Yeah, because you could do so there's 4 minus x. You could technically do the minus x part, but the 4 part you couldn't do. So it's not possible anyway. But you would just have to set it up for the most part. Okay. So I'll say again, I think the hardest part of this problem is getting the volume of that rectangular sheet. I don't think anything else is that bad. Okay, and then at a certain point, it's just force times distance and plug it into the integral, right? I think the hardest part, or the part that may be the least intuitive, is just working this out. Okay, but that's what you need to do. You need to draw the picture and then see what's your length is generally gonna be the same thing, but your width might change. So you need to kind of look at the side, look at what equations are a part of it, look at what's happening, see what shapes you can make in order to get that width. Okay, in this case, we could just use a triangle. In other cases, it might be different. Yeah, absolutely. What do you want to draw then? About y equals 8. Okay, so yeah, let's look at that real quick. So what is y equals 4, y equals 8? Are those horizontal or vertical lines? Are y equals 4 and y equals 8 horizontal or vertical lines? the horizontal lines, right? So let's say here's x squared. And then we have y equals 4 and y equals 8. Right? So it says the region bounded by x squared and 4. Where is that on the spectrum? This is y equals 4. Y equals 8. Where is this region? It's this one, right? Good. So that's in here. Okay, and I want to rotate this about y equals 8, right? So I have a function of x. Should I draw my rectangle vertically or horizontally? Should I draw it like this or like further? Good. Okay, so if my rectangle is vertical and I'm flipping around here, is that disc and washer or is that shell? It'll be washer because this rectangle is perpendicular to the axis I'm flipping around, which I don't look like you're figuring out there. So good. So what do we need for washer? We need two things. We need an outer radius and an inner radius. So what is my outer radius? What is it? And why is that? That's right. Right. Good. Wait, actually. Oh, I guess no. Sorry, I didn't think of it. So my outer radius needs to be this distance, right? So what is this distance? Is it x squared? No, because this is the x squared distance, right? I need to go, so I don't want this distance, I want this one. So x squared is a part of it, but it's not x squared itself. Good. Awesome. Yeah, so it's good to draw lines on there. That's what I should have done there. I should have explained that, but 8 minus x squared is the outer radius. So now the inner radius is just to here. So what is that? Right. Right. So that one coincidentally ends up being 4. I should write 8 minus 4 just to not get confused because it won't always end up like that.
Yeah, this is my confusion.
This is your confusion? Well, what's this distance? It's 8 minus 4, right? Why is it 8 minus 4? Because that's the distance we go, right? So that will be 4. Does that make sense? Am I answering the question or is it okay? Very good. So then our integral, right? So we need to figure out where we intersect here. How do I find those points? Yeah, so you get -2 and we get +2. Okay, so we're going to integrate from -2 to 2, and then you have pi, right? Because we're using washer, and then we take the outer radius squared, 8 minus x squared squared, minus the inner radius squared, which is just 4. Okay. Thank you. Is that good? Does that make sense? Yeah, no problem. Cool. Questions? Did you have a question?
Yeah, it's not related to.
No, that's fine. Yeah.
Talked about taking that one class online,
Which class online?
the one math class you said you took online.
Oh, are you talking about the one where I was talking about you split? Yeah.
How does taking a class online work? Because I planned on taking multivariate online
So-
this summer.
My so it depends on the teacher sometimes. Actually, do you mind? I'm gonna real quick just wrap this up here.
Oh,
So
yeah.
it looks like everybody left. So okay, we're gonna go ahead and stop. Thanks for watching. Bye.